I started with this sample, which was a little bit of a granulated holmium metal. It was 1.606 on the scale, and I've got it 9.42529 gigahertz. Magnetic field is at 3,350 or 60 Gauss. So the current weight is 1.5795. So it looks like it went down a little bit. I'm going to play around with the magnetic field and see if I can change that. I'm not seeing any change in the absorption here on this little on this spike. And this is continuous wave. So I'll change the dial a little bit here. So these are the new samples I made. I made one like this with holmium, granulated holmium metal in it. But the holmium one is down there in the hole. Okay, so the microwave source is off at the moment, and the magnetic field is off. So it's coming up a little bit. It's probably going to go back up to 1.6. So the thing about holmium is that it's quite strongly paramagnetic. You can see how it responds to this magnet here. Here's a thing to try. Gallon stand. That I want to try too. Looks like these values are coming up a little bit, back towards 1.6. I'm going to turn the RF on again. First I'm going to turn on the magnetic field. Because I think that the weight loss that I saw has to do with the magnetic field. .594 is the current weight. 1.58, let's see here. Take it up to 3,300 Gauss or thereabouts. 336 is kind of where. Yeah, so the weight is going down to 1.576. So that's 3,360 Gauss. Weight. Current weight is 1.5. Yeah, it went down a little bit. Okay, I'm going to turn the RF on here. And I'm getting a lot of noise, a lot of distortion here, which is, I don't know if that means anything. Alright, so I'm just going to play with the dial here and see if I can get it kind of optimized on. It's on continuous wave right now. I'm going to pulse this at 10 pulses per second for fun. Current weight is 1.575. Pulsing 1.5799. 5788. Magnetic field 3350. So I went to 5 pulses per second, and this dropped from 1.58, 2 or 3 down to this. .577. Magnetic field's at 3320. It's really not a very fine tuning method I have here. It's kind of coarse. .576. So there's been a small change. I'm going to slow this pulses per second down here. See if that does anything. 580, 586, 3 pulses per second. 5.7. Looks like maybe 6 pulses per second. Seems to work pretty well. I'm going to tweak the magnetic field a little bit. $33.50, $33.60, $3,400. Man, this is hard. Very, very touchy. $33.40 again. $3,300. $32.30. I'm going to go back up to $33.60. $36.20. 36. Oops, I'm going the wrong way. 33.60 right there. Right there. 33.60. 33.50. It's touchy as hell. I don't know. Maybe there's something. Seems like there's something going on with this. I'll have to revisit it later. Here is the readings on the holmium sample now after a while. And all the power has been shut off. Let's come back up. Holmium sample in there. Pulsing at 10 pulses a second. I got the frequency 9.4228 gigahertz. I locked in the magnetic field 3362 on constant current. I figured out how to get it dialed in really accurately. Finally. So mathematically, by theory, that should be the resonance point. I calibrated this meter, so I'm thinking that that's giving me a true reading, but there's still a little bit of error. So I don't know, the readings are going up 1.33, they were 1.31. So it's still going up and down a little bit. I don't know if it's anything. I'm going to try a different material. Okay, we got bismuth powder in the hole now. In at 3.397. bismuth, our old anti-gravity pal. No. So it's on continuous wave right now. I'll start pulsing at 1 hertz. Nice. Goes up to 3.4. Maybe there might be something. Five hertz. $3,400 ghosts. $3,430. Bismuth has disappointed me yet again. So this is nickel tin. Nickel tin. $2.77 2.77 grams. 771. Continuous wave. 2.771. 3362 Gauss. All right, 10 hertz pulsing. I'll sweep the width of the field. Actually, I'll turn it on continuous wave. Well, I'll do this part. 3350 Gauss. No change on the weight. Now I'm going to go back down. 3390. 380. 3365. No change in the weight. 50 hertz. 100 hertz. Nada. Next. Okay, so now I got a little sample of lanthanum oxide. 0.543 grams. The same magnetic field, 3362 Gauss. 543. Turn on. Oh, the microwaves are on. Okay then. Okay, that's continuous wave. Also back on here. I should have the mirror up off. No change. RF back on. Pulse it now. Say 1 hertz. Ten hertz. Okay, try the next sample. Okay, last sample I'm going to try this way tonight is Holmium Oxide. because I had good results with that a long time ago. But I haven't tried it in this machine, in this setup here. So we're starting at 1.007 grams. So no immediate change with the microwave's on. Continuous wave. Try pulsing it. 5 pulses a second. Seeing a bit of movement. That's the Holmium Oxide powder, and that's straw, and the TE102 cavity. It appears to be moving a little bit. It's being pulsed at 1 hertz. That is 1 pulse of microwaves every second. 1 second on, 1 second off, 1 second on, 1 second off. tiny bit of movement there. You can see it on the hook. Samples jittering around down there in the cavity. It should be at the resonant frequency, the EPR resonant frequency. Yeah, you can see it. See it jittering around in there. It's experiencing a force from the microwaves. It's at 10 hertz now. Looks like the weight's gone up about 20 milligrams. Yeah, there's a tiny bit of movement there. I can see it on the hook. Sample's jittering around down there in the cavity. It should be at the resonant frequency, the EPR resonant frequency. So I turn up the pulse frequency to 10 hertz. If you can see the sample down there. It is jittering. I'm going to turn it up more. Okay, turn it up to 50 hertz. I turn it up to 50 hertz there. Should be able to see some jittering. That's holmium oxide in there. I asked the professor of spectroscopy here, and he didn't know if this was known in physics, if these things would actually experience physical forces. Okay, that's at 60 hertz. Look at the string. On the camera there, look at the string shaking. And the sample in there shaking around. Although it's not really losing or gaining weight, but you can see movement there. I just turned the microwaves off. See if it calms down. Okay, I just turned the microwave source off, so I thought that would stop the jittering, but it doesn't. So maybe I was wrong about that, but I don't know what's causing the jittering. because this fishing line around here is not moving. Well, the jittering still seems to be there with the microwaves off, so I don't know what it is. I don't think it's air movement, because there's other fishing line in the area that's not moving around, so I don't know.
Fail for research anti-transmission from Vulcan Space Lab.